Good morning, colleagues. Special greetings to the class of 2021 Grade 12 learners. My name is Maletsatsi Bless. I'm a subject advisor for mathematics in Mutewa District. It is always a pleasure to me to come here to share lessons of mathematics with you learners, and I hope that you are going to benefit from this session. Today, learners, we are going to do differential calculus. And then for differential calculus, learners, we are going to focus on sketching of a cubic function. I hope that now you are on par with regard to determining the gradient from the first principle, differentiating by making use of the rules. As for today's lesson, we'll be focusing on sketching of a cubic function. And then you'll recall, learners, that calculus forms part of mathematics paper 1 examination, which contributes about plus or minus 35 marks. And then calculus is one of the topics where you can be able to collect a lot of marks. Without wasting any time, sketching of a cubic function. Cubic function has a general form of f at x is equals to ax cubed plus bx squared plus bx plus d. This is the general form of cubic function. As you can see here, it has been raised to the third degree. The moment you see the highest power being 3, you should know that we are dealing with the cubic function. Like with quadratic function, you know that it has got the general formula, which is ax squared plus bx plus c. We have linear function, it has got its format as well. But as for the cubic function, we have f at x is equals to ax cubed plus bx squared plus bx plus d. Now, what you need to do when sketching a cubic function, I normally call them golden rules to sketch the cubic function. Number 1, shape is very important, learners. Shape is very important. You need to determine the Y-intercept. For X-intercept, for Y-intercept, you let X to be 0. And then for X-intercept, you let Y to be 0. Turning point, as well as the point of inflection, where second derivative is equals to 0. These are the golden rules to sketch the cubic function. Now let us unpack each rule. All right, now, as I indicated earlier on, that the format is f at x is equals to ax cubed plus bx squared plus cx plus d. Now we know that d here represents the y-intercept. Now, with regard to the shape, learners, you'll recall, most learners, with the quadratic function, the value of a plays an important role in determining the shape of the graph. When we're dealing with the straight line function, no, the cubic function, we used to say if the value of a is greater than 0, we know that we are going to have what we normally say, we were saying is a set face. When the value of a is greater, it's less than 0, we are going to have what? The happy face. Therefore, this one is its maximum, and this one is its minimum TP. Now, the same applies, learners, with the cubic function. If the value of a is greater than 0, meaning if the value of a is positive, this is the shape that we are going to get. It begins by increasing, decreasing, and increasing. That's if the value of a is greater than 0, positive. If the value of a is less than 0, meaning negative, this is the shape that we are going to have. It begins by decreasing, increasing, and decreasing. Now, it is very important, learners, before you can sketch the cubic function, to check the value of A, the coefficient of x cubed. It will inform you about the shape of the graph. Number 2, you need to determine the turning point or the stationary point. Now, at the turning point, we know that f prime of x is equals to 0. When I say f prime of x, I'm referring to the gradient. The gradient at the turning point is equals to 0. Now, learners, just to take you back, suppose I have this shape. Say the value of A is greater than 0. And then we know that the function will start first by increasing, decreasing, and increase. That's if the value of A is greater than 0. Now we are saying the turning point. This is the turning point. We have the turning points here. We have the maximum. This one is a max. It's a max TP. And then we have the mean TP. Now, we are saying that at the turning point here, we are saying f prime of x is equals to 0. By f prime of x is equals to 0, we are referring to the gradient. The gradient at the turning point is equals to 0. Suppose maybe if I'm to draw a tangent line to this curve here, remember it touches a curve at one point, and then from grade 10 and 11, you know that the gradient of the horizontal line is always equals to 0. The same goes for the minimum turning point. F prime of x here is equals to 0. Therefore, at the turning point, the gradient is equals to 0. Very important. Now, suppose that, remember this function, it is increasing, turning point, decreasing, turning point, increasing. Now, at the turning point, we said f prime of x is equals to 0. Now, what about if I have, say, a tangent line this side? Therefore, in this case, we are saying that this function increases. And as it increases, we are aware that this line slopes to the right. It means the gradient here will always be greater than 0. I normally say to my learners, just indicate by the plus there, just to indicate that this function is increasing. The line slopes to the right. It means the gradient is positive. The gradient is greater than 0. Likewise here, we normally indicate with the negative line to indicate that this function decreases here. Therefore, what is the gradient here? F prime of x here will be less than 0. F prime of x is less than 0, and this function decreases. This side, this function increases. The same goes for from the turning point here up there. Therefore, we know that this function here, it increases. And then what happens to the gradient? If I'm to draw a tangent line to this, it means the gradient here will also be positive because the line will be sloping to the right. Therefore, f prime of x here is what is greater than 0. We're having f prime of x here is greater than 0. At the turning point, f prime of x is equals to 0. And then here, the function decreases. Therefore, f prime of x is less than 0, decreases. Again, here, our function is increasing. Therefore, f prime of x is greater than 0. You should remember this, learners. All right, now moving right along. I was at the turning point. Then I was explaining to you that at the turning point, f prime of x is equals to 0. Now, if you are to sketch the cubic function you still need to determine the turning point. Therefore, you differentiate once, and then you equate it to 0, and then from there you'll have something of this nature. Suppose this is our given function, and then from there you will factorize this, or you'll make use of the quadratic formula to determine the values of x, and thereafter you substitute the values of x into the original equation to determine the corresponding y values. I said we determine shape. Number 2, determine the turning points. At the turning point, f prime of x is equals to 0, and then you differentiate your function, you equate it to 0, then you determine the x values, and thereafter you substitute these x values into the original equation to determine the corresponding y values, and then from there you'll have your turning points. You'll have the maximum turning points as well as the minimum turning point. One other thing that you need to take note of, learners, as in when you determine the turning points, if the x or the y value of the turning point is equals to 0, then that point is also an intercept. Very important. If the x or the y value of the turning point is equals to 0, then that point also serves as the intercept of that function. Very important, learners. And then from there, you need to determine the x-intercept. We know for the x-intercept, we let y to be equals to 0. Then when dealing with the cubic functions, determining the x-intercept is very important, learners. Now, firstly, you need to check if your given equation can be factorized. If it can be factorized, then you can be able to determine the x-intercepts. Now, if it cannot be factorized, I think we're going to have to find the first factor. We're going to have to find the first factor, and then that can be obtained by making use of the Factor Theorem. And then for that, you'll recall, learners, we'll have to guess on this one, and then we'll have to use the method which is called trial and error. Then you'll keep on substituting if x is equals to 1 into your original equation to see if you'll get 0. If you don't get 0, you'll have to try 2 up until you get 0. And then from there, once you get 0, say maybe if x is equals to 2, you get 0. Then it means that x minus 2 will be the factor of that a function. But for this one, learners, I think we're going to use the calculator because it simplifies our work. We don't have to go via trial and error because it is time consuming. Likewise, if the value of x is minus 3, you substitute in the equation, you get 0, then it means x plus 3 will be the factor of the function. Now, once you have the first factor, it means you'll have to determine the other roots. Once you get the first factor, you'll have to determine the other roots. And the other roots can be determined by using long division method or the synthetic method, or you can use the inspection method. And then that's the beauty of mathematics, learners. There are so many ways to kill a cat. What is very key is to arrive at the same answer. Now, that's how we determine the x-intercept of the cubic function. That's how we determine the x-intercept of the cubic function. We let y to be equals to 0, and then from there you factorize if it's possible. If it cannot be factorized, then it means we'll have to use the factor theorem to determine the first factor. And then from there, you'll keep on doing trial and error up until you get 0 when you substitute into the equation. Then when you get 0, for an example, if x is equals to 2, it means x minus 2 will be the factor of that theorem. Then for you to determine the other roots or the other factors, then you'll have to choose whether you use long division method or use synthetic method or use inspection method. All right, now I'll take you through that as in when we work with the activities, learners. Now, one important thing that I want you to keep in mind when determining the X-intercepts. Learners, for repeated X-intercept, at times you'll find that when you determine the X-intercept, you get X is equals to 2 and X is equals to 2. Or maybe as a factor X minus 2 into X minus 2. And then in that case, it means we are having the repeated X-intercept. And then with the repeated X-intercept, you should know that it plays two roles. When you come across such, it means that repeated X-intercept, it plays two roles. The first role, it says to you, I'm X-intercept. Secondly, it says, I'm also the turning point. It says that I'm the X-intercept of this function. Again, I'm the turning point of this function. Very important, learners. You know, learners, your brain likes colors. When you come across that, make use of the color pen and you write down two rules, X-intercept as well as the turning point. Very important. Moving right along, we are still looking at the golden rules to sketch the cubic function. Number 4, you need to determine the Y-intercept. You'll recall from our general format, I did indicate to you that D represents the Y-intercept. But from the previous grades, you know that for Y-intercept, you let X to be equals to 0. And then for that, then you'll substitute X into the original equation being 0. Obviously, we'll be left with Y. Therefore, D value represents the Y-intercept. Lastly, learners, you need to determine the point of inflection. That one, it will depend on the question. And then for point of inflection, firstly, you need to understand what is the point of inflection. When you talk of the point of inflection, we are saying that it's when the graph changes its concavity. It's when the graph changes its concavity. Learners, you'll recall from the shape, we said that if the value of A is greater than 0, if it's positive, this is the shape. It begins by increasing, decreasing, and increasing. Now, if you can check on this function, you realize that we have concave down, and then we have concave up. We have concave down, then we have concave up. Now, the point of inflection is when the graph changes its concavity from concave down to concave up, or vice versa. Now, at the point of inflection, we know that second derivative at the point of inflection, second derivative is always equals to 0. At the point of inflection, second derivative is equals to 0. And then from there, it means you differentiate twice, and then you equate that to 0. And then you solve for the value of X. And thereafter, you substitute the value of X into the original equation to determine the corresponding Y value. And then you'll have your point of inflection, where the curve changes its concavity. Alternatively, the X-coordinate of the point of inflection can be obtained by adding the X values of the turning points, meaning x1 plus x2 divided by 2. If you know the coordinates, if you know the X values at the turning point, you can add those values of X and then you divide by 2. You'll get the X value at the point of inflection, and thereafter you'll take that value of X and substitute it into the original, then you'll get the corresponding Y value. All right, learners, I hope we are together thus far. In terms of concavity and the point of inflection, learners, you'll recall that I said it occurs when the concavity changes. And then we said that second derivative is equal to 0 at the point of inflection. As you can see here, learners, we are having this cubic function. I think the value of a here is less than 0 because it begins by decreasing, increasing, and decreasing. Now, when you check at this function, we have concave up here. We have concave up. We have concave up. And then you should also remember, learners, for concave up, for concave up, second derivative of x is greater than 0. For concave up, second derivative of x is greater than 0. Now from there, here is the point of inflection. Here is the point of inflection, which is obtained by determining second derivative and equating it to 0, and then solving for the value of x. After determining the value of x, you substitute that value of x into the original to get the corresponding y value. This is the point of inflection. It means we're having the concave up, then at this point of inflection, now the concavity changes now. It was concave up, now it becomes concave down. What is very key? At the point of inflection, second derivative is equal to 0. For concave up, second derivative of x is greater than 0. For concave down, second derivative of x is less than 0. Very important, learners. Very important. At the point of inflection, second derivative is equal to 0. Remember, the point of inflection is when the graph changes its concavity. And then for concave up, second derivative of x is greater than 0. You should remember this. You should remember this. And then for concave down, second derivative is less than 0. Very, very important, learners. Now, learners, these are the golden rules to sketch the cubic function. These are the golden rules to sketch the cubic function. You determine the shape of the graph. You determine the turning points. At the turning points, first derivative is equal to 0. You determine the x-intercept. For x-intercept, y is equal to 0. And thereafter, you determine the y-intercept. For y-intercept, x is equal to 0. And then from there, you will determine the point of inflection. At the point of inflection, second derivative is equal to 0. And then you solve for x, you get the value of x, and you substitute it into the original equation to get the corresponding y value. Alternatively, you can make use of this if you know the x values at the turning point, you add them and divide by 2. You'll get the x value at the point of inflection. You substitute that into the original equation to determine the value of y. These are the golden rules to sketch the cubic function. All right, now let us see, learners, if we can be able to apply these golden rules to sketch the cubic function. To sketch the cubic function, you remember earlier on, I touched on the gradient at the turning point, or is equals to 0. Very important, learners. All right, moving right along now. Suppose that we are given this question. Suppose that we are given this question, and then you are required to answer these questions, and thereafter you sketch the cubic function. Now, learners, we are given the graph of f at x is equals to x cubed minus 4x squared minus 11x plus 30. And then 1.1, you are required to calculate the y-intercept of the graph of f. 1.2, you calculate the x-intercepts of the graph of f. Number 3, you determine the coordinates of the turning point. 1.4, you draw a neat sketch of f, clearly showing all the intercept and the stationary point. 1.5, you find the x-coordinate of the point of inflection of f. This question is specific. you determine the x-coordinate of the point of inflection of f. You don't determine the coordinates of the point of inflection. It means you're only focusing on the x value. And then this will be the follow-up questions as well. For which values of x will f at x be concave up, be concave down? F prime of x is equals to 0, f prime of x greater than 0, f prime of x less than 0. All right, let us see, learners, how best can we answer these questions based on those golden rules to sketch the cubic function. All right, and let us go back to our question. We're given the function. We're given f at x is equals to x cubed minus 4x squared minus 11x plus 30. All right, the first question there, we are required to calculate the y-intercept. All right, learners. Now, (1.1), we are required to find the y-intercept. We know that for y-intercept, we let x be 0. Therefore, it means if we are to substitute by x is equals to 0 into our equation there, you can see that we're going to have 0 here. Ultimately, the y-intercept will be equals to 30. Remember, we said d gives us the value of the y-intercept. Therefore, for y-intercept, learners, for this one, we'll have 0 and 30. Now, I'm aware that I'm going to sketch the function. Therefore, I write everything in coordinate form because I'm going to sketch the cubic function. Now, we are done with 1.1. And then from there, 1.2, we are required to calculate the x-intercept of the graph. Calculating the x-intercept, we know that for x-intercept, we let y be 0. And then from there, we need to check first if this can be factorized. Then we have x cubed minus 4x squared minus 11x plus 30. Therefore, y is supposed to be, therefore, we equate everything to 0. And then this cannot be factorized. Then it means now we'll have to make use of the factor theorem to determine the first factor. We'll have to determine first factor by making use of the factor theorem, and thereafter we'll be able to determine the other roots or the other factors. Now, you'll recall earlier on I indicated to you that for that one, trial and error, it takes a lot of time. Therefore, for this one, I'm going to show you how to use the calculator to determine the first factor. Now, what you need to do, learners, with the calculator, you'll have to switch on your calculator, and then from there, you need to press on the mode, and then from there, you need to choose option number 3, and then from there, you need to punch in the equation or the function. We have x cubed minus 4 alpha x squared minus 11 alpha x, and then plus 30. This is our cubic function. And then from there, you press equals to, Then it will display G at X. You press equals to again. And then from there, where are we going to start? I'm going to encourage you learners here. We start maybe from, to play safe, -5 up until 5. And then you just punch in -5 up until 5 is there already, equals to step. It goes with 1, 2, 3, and then it's okay, you press equals to. And now when you check here, learners, we are having 2 columns here. Remember, learners, here we are determining the first factor. We're not going to use trial and error, but rather we're going to use the calculator. And then we're having 2 columns. And then the first column, it's X values. The second column, Y values. We have X, we have F at X. You know F at X is Y. All right. Then from there, what you need to do, we are going to focus on the Y column. We're going to focus on the Y column. On the Y column, we are only looking for 0. We want to see where is 0. Where is 0? All right. Then from there, we can see that at number 3 here, we're having 0 here for Y. Y value is 0. And then what is the X value? The X value is -3. And we know, learners, that when Y is 0, we are having the X intercept. Right? When Y is 0, we are having X intercept. It means wherever you see 0, you should know that we are having the X intercept of the graph that we have punched in. Now, therefore, we are having 0. It means we are having X. On the other side, it's -3. Therefore, 0 goes with -3. It means the first X intercept is -3. The first X intercept is -3. Then from there, what we are going to do, we're going to say, okay, now we are aware that it means when you substitute -3 into this, you are going to get 0. Therefore, we are saying, therefore, F at -3 is equals to 0. Therefore, X plus 3 is a factor. X plus 3 is a factor, learners. Then we can check other zeros as well, but remember, we just need 1. We need to determine the first factor. You can see at X, we're having Y is equals to 0 there, and then we have 2 the other side, but we're only interested in 1 0, then the rest will leave them. Now, we are aware that at X is equals to -3, therefore the whole thing becomes 0. Therefore, X plus 3 is our factor. Now, with this now, we are going to determine the other roots of this equation. We're going to determine the X-intercepts of this function. Now, I'm going to make use of the synthetic approach, learners. And then I'm going to make my table here. And then we said X is equals to -3, right? And then from there, I'm going to write the coefficients of this function. The coefficient of X cubed, we have 1. Of X squared, we have -4. And then here we have -11. And then we have what? We have 30. These are the coefficients of this function. We have -1. We have we have 1. We have -4, we have -11, right? And then we are having 30. Therefore, these are the coefficients. And then from there, what we are going to do from this, I'm going to draw, I normally call it a gate. I normally call it a gate. This is what I'm doing. And then from there, now, this is my gate. All right, now, for this one, I'm going to write 0, or you can just drop that one here. Then from there, what I normally tell my learners is that inside the gate, you add. Inside the gate, you add. Outside the gate, you multiply. Outside the gate, X is equals to -3. We multiply there. Now from there, I'm going to say 1 plus 0 is equals to 0. It's equals to 1. It's equals to 1, sorry. Is equals to 1, and then we're going to multiply 1 by -3. Then we're going to get -3. Inside the gate, we add -4 minus 3. It's -7, right? And then -7 multiply by -3, right? This will be 21. And then from there we add minus 11 plus 21. This will give us what? This will give us 10, right? And then 10 multiplied by minus 3, we get minus 30, right? And then from there you add inside the gate, therefore you get what? You get 0. Therefore every time here you should get 0. If you don't get 0, you should know that something is not right. Something is not right. And then from there, from this we have the value of A, we have the value of B, and then we have the value of C for quadratic equation. And then it means we are going to have x squared minus 7x plus 10. Remember, we're determining the x-intercept, and for the x-intercept, we said y is equals to 0. And then from there, remember, we're determining the x-intercept. You need to factorize this to determine the other factors. Therefore, we're going to factorize this, or we can use what? You can use quadratic formula. And then we have x. The last term is positive. It means we're going to have the same signs. Then you check the middle term. It's a minus, right? Then we have 2, then we have 5. Now, the moment you write these factors, you need to drop the first factor that we have obtained, which is x. It was x plus 3, right? All right, now this is what we have. And then it means for this one, therefore, 0 factor law, x is equals to minus 3, or x is equals to 2, or x is equals to 5. Now we have our x-intercepts. Remember, we are going to sketch the cubic function. I'm going to encourage you learners to write this in coordinate form as we did with the y-intercept. Then we have negative 3 and 0. Then we have 2 and 0. And then we have 5 is to 0. Now we have our coordinates of the x-intercept. All right. I think we are done with this question. And normally it carries about 4 marks, this question. It carries 4 marks. For y-intercept, just a mark. And then moving right along, 1.3, with 1.3 learners, here we are required to determine the coordinates of the turning point. Determine the coordinates of the turning point. Now we know, learners, for turning point TP, I'll indicate by TP, we are saying f prime of x is equals to 0. F prime of x is equals to 0. Now what we need to do, it means we'll have to differentiate our cubic function. You'll recall we are having f at x is equals to, we're having f at x is equals to x cubed minus 4x squared minus 11x plus 30. This is our cubic function. 1.3. At the turning point, f prime of x is equals to 0. This is our function. Then we need to determine f prime of x. And then for this, we know that we're going to differentiate. Therefore, we're going to have 3x squared minus 8x minus 11. It's first derivative. And we said that at the turning point, first derivative is equals to 0. It means I'm going to equate this to 0. I'm going to have 0 is equals to 3x squared minus 8x minus 11. Done. Now what we need to do now, remember the question, we're required to find the coordinates of the turning points. We're required to find the turning points, the coordinates of the turning points. Right, now it means we'll have to factorize this, or we can use the quadratic formula. I think I'm going to factorize this one. All right, you'll help me with this one. We have 3x, right? Then we have x I think we have minus 11, and then we have plus 1. Are they correct? Let's verify if they are correct. Let's multiply the inners. We are having minus 11x, the outers. We are having 3x multiplied by 1, it gives us 3x. Then when we add this, we should get the middle term, which is minus 8. Yes, they are correct. Then from there, saying 3x minus 11 is equals to 0, or x plus 1 is equals to 0. Then from there, the first value of x at the turning point will be equals to 11 over 3, or x will be equals to negative 1. Okay, sorry, learners. All right, as I was saying that we are going to factorize this, and then we are having our factors as being 3x minus 11 into x plus 1. And then from there, we need to check if these factors are correct, right? And then from there, we multiply the inners, we get minus 11x. We multiply the outers, we get 3x. And then from there, we add to check if we'll get the middle term. Then we have minus 8x. It means our factors are correct. Then from there, we apply 0 factor law. 3x minus 11 is equals to 0. Therefore, x is equals to 11 over 3. Or x plus 1 is equals to 0. Therefore, x is equals to minus 1. Therefore, these are the coordinates. These are the x values at the turning points. These are the x values at the turning points. And then we need to determine the corresponding y values. We need to determine the corresponding y values. And then we know that for x is equals to 11 over 3. Therefore, what will be the value of y at x is equals to 11 over 3? Then you take your calculator. And then we have, remember, every time you substitute the values of x into the original equation, learners. If you substitute into this one, you'll always get 0. You need to substitute the values of x into the original equation. Now let us check now what will be the corresponding y value if x is equals to 11 over 3. And then I have, okay, I have 11 over 3 cubed minus 4 into 11 over 3 minus 11 into 11 over 3 and then plus 30. Something is not right here. Let me check this. This is squared. We're having 11 over 3 all cubed minus 4 into 11 over 3 squared minus 11 into 11 over 3. And then from there we have plus 30. There we go. Then for x is equals to 11 over 3, the corresponding y value will be minus 400 over 27. And then for x is equals to negative 1, f at negative 1. All right, we just have to go there. And then we replace 11 over 3. Divided by minus 1. All right, same goes here. All right, then negative 1. I think there's a mistake somewhere. Let me check that. Where did we go wrong? It's minus 1 all cubed minus 4 all squared minus 11 into minus 1. We need to remove this bracket, okay, and then plus 30. Then we have the value of y as being 36. When the value of x is equal to -1, then the corresponding y value is 36. Now we need to write this in coordinate form. We need to write this in coordinate form. And I normally encourage my learners to start first with the small value of x. Therefore, we'll have -1 and 36, the first TP. And then the second TP will have 11/3, which goes along with -400/27. All right, and then for this one, let us write it in decimal form because we're going to plot our graph. And then what is 11/3? 11/3, and then this is what this is. Then I think this will be 3.7. That's the first coordinate, and then minus 400/27, and then we have -14.8. This will simplify our work when we sketch the cubic function. I think we are done. We're able to find the y-intercept, the x-intercept, the turning point, the coordinates -1 and 36, and then we have 3.7 is to -14.8. Now with this information, now we need to plot our graph. 1.4, it says that now you need to draw a neat sketch of f, clearly showing all the intercepts and the stationary points. All right, now let's see if we can be able to put this information on the graph. All right. All right, you could call our y-intercept quickly so that we can plot this. And then we have 0:30, and then 1.2. The x-intercepts, we have -3 and 0. We have 2 and 0. And then we have 5:0. Okay. And then 1.3, turning point, TP, first TP, we have -1:36. Second TP, we have 3.7 is to -14.8. Now we need to put this information on the graph. Remember, our graphs are not drawn to scale. But at the same time, everything should be clear. All right, now let us try to put this information on the graph. And then we have this. We have 1, 2, 3, 4. We have a 5. Then we have -1, -2, -3, -4. Let us start first with the x-intercepts. We have -3. We have 2. And we have 5. Now these are the x-intercepts. And then from the y-intercept, we have 0 and 30. Let me extend this. All right. Suppose we have 30 somewhere there. All right. Now we have a point here. This is our y-intercept. And then from there, we need to plot our stationary points. From this information, learners, you'll recall most when you check our cubic function. When you check our cubic function, we have f at x is equals to x cubed minus 4x squared minus 11x plus 30. It means that the shape of the graph the value of A, the value of A is greater than 0, we are expecting a function of this nature. This is what we are expecting. This is what we are expecting. And then from there, let us now plot our turning points. It goes without saying that for the smaller value of x, we're going to have the maximum turning point. And then for this one, it will be the minimum turning point. You need to classify that even before you sketch your cubic function. All right, now for the maximum turning point, we have x is equals to -1. It goes along with 36. Remember, not drawn to scale. Then I'll have a point somewhere there. Remember, this one is what? This one is it's a maximum. It's a maximum turning point, right? And then we have the minimum turning point. The x value is 3.7. 3 is here, maybe 3.7. It could be somewhere there. And then it goes along with what? Goes along with, say, maybe we have -14.8 somewhere there. We just estimate here, learners. Then it means we will have a point somewhere there. Therefore, remember, this one is what? This one is it's a maximum turning point. This one is a maximum. I mean, it's a minimum. Having the minimum turning point, that one is a maximum turning point. And then from there, we need to sketch our cubic function. From the value of A, we are expecting to have the shape from the